Here are the identities for you to learn. Sorry you were not in class and you missed it. Is anybody missing though? Who are we missing? Who's that front seat? Who? Brielle and Larissa. Brielle and Larissa, it's your own dang fault. Hold them there, huh? Okay, another name, ladies and gentlemen, for one here, okay, is this, right? Could I say, I'm going to come back to it. I'm just showing you there's multiple ways. And that's how sometimes people get frustrated. Because in math, a lot of times you guys have always been succeeded because you follow a specific way, correct? Where some others have found those learning opportunities, but some haven't as well. So they kind of get a little struggling. Does everybody understand how this way also works? So right there, we already know that this guy is sine squared, but is there a negative sine squared? Look right here. So as I go through, cosine squared of x minus cosine squared of x minus sine squared, what happens? They cancel out, and so that's why it's negative sine squared as well, right? So as we already said, we have sine of x times negative sine squared of x, which is negative sine cubed. Now, sometimes you guys might wonder, why do I use this? What's the purpose of trig identity? It's calculus. When in calculus, we're going to get to derivatives and integrals. And when you're able to simplify them, it's a lot easier to do those items. So it's just making your calculus life a lot easier. Who was before, jerkhole? Whoa, whoa, whoa. She's good. Well, yeah, but... Huh? She loved Miss Rizzo, huh? Is it Miss Rizzo? Frizzle? Can anybody tell me what example 2 in the book was again? So I can start it off. Example 3, excuse me. Flip your page. Flip your page. I guess I could look back here. This one? Okay. Okay. So the goal of this is to factor it. But I can't factor it right now because I'm in 2 different trig identities. It's kind of like saying y squared minus x minus 3. Can I factor y squared minus x minus 3? No. But what is cosecant squared? What's another name for him? Does everybody see that in your identities? 1 plus cotangent squared? That cosecant squared is 1. And remember, when we see something squared, it most likely we can move. Check that, Bia. I'm playing some chess over here, and I just put my cousin in check. What do we say this was? Cotangent, right? So what's another way to write this? Cotangent squared of x minus cotangent of x minus 2. Yes, no, maybe so? Because now, if we looked at this, oops, that's a U, not a D. If we saw u squared minus u minus 2, would you guys see that I could factor that a lot quicker? You just have to train your eyes that this and this are roughly the same idea, huh? We could use u substitution if you think of it. Who's our u? Cotangent, huh? Okay, so therefore this is cotangent x minus 2 and cotangent of x plus 1. How would you factor this guy? Wouldn't this be u minus 2, u plus 1? But who is our u? Cotangent. Here's to your mamas. Run away. Ooh, somebody. Okay, onward! By the way, you might want to know, what's this again? Remember what those are called? Not a perfect square. What's this? What's another name for this sign? What is it? Difference of squares. And what do difference of squares factor into B? Anybody remember? What is that called? Let's make that a 4 so it's easy. Conjugate pairs. Difference of squares go into conjugate pairs. You might need to use that today in your homework / test. Not test it, but your homework or your test. They got a little bit freaked out over there. Dunk? Yeah, but you work at Little Sleezers, huh, Dunk? Do you like some crazy bread, Dunk? I love me some crazy bread. What is your main job at the old Sleezers? You make a pizza. I got you, Dunk. Do you have a job, Connor? Isaac, what do you do? Nice. Brady? Nope. 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 Kinda. What do you do? Oh. What do you do? Huh? Nice. Daniel Layton? Nice. Nice. Nope. Lil? Nice. You're one of those people. I can't stand watching my own kids. My wife says, I said, I get to babysit the kids tonight. She's like, it's not called babysitting. It's called taking care of. They're your own. You don't get paid. And I'm like, touche. Huh? True. Okay. Trek, can you just hand me my book? I'm in a lazy mood today. My as Cooper called it, he's like, were you acting like Tigger this morning in driver's ed? I'm like, yes, I was. And now that's wearing off. Because, yeah. I like to go to the bathroom. It makes me feel really good. Just how about you guys? Yeah, it's a nice releasing sensation. Sorry for making you think about that, but it does. We all know. Where you've been holding it for a long time because your dad won't pull over the dang car. I'm not that father. It's my wife that's that. I'm like, hey, let's pull over. My kid's got to pee. She's like, we just peed 5 minutes ago. I'm like, we still got to go. No. What do we think, guys? What do we think? Let's not shout out. Let's raise of thy hand. Not you. You've already shouted a lot today. I know. Okay, so hold on. I might come back to you. Laura Burton. Speaking of Miss Burton. I plan to attend. However, my husband is supposed to be coming home from the 2-week training, so I might have to be ready. What the hell? Does anybody know if that's good? Yeah. All right. Scares me. Anybody have an idea? Had, do you have an idea? Is? You are so good. Is that your idea, Buckwheat? Yes. What did you want to do? What were you thinking, though? No, it does not. Does not equal. Okay, be aware. Yeah. So understand, he said, just to be off on topic, because we know that 1 minus sine squared of x equals cosine squared. I see a lot of kids do this. Okay, I see a lot of kids say, oh, then 1 minus sine is cosine. No. Never, 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 never. Never, 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 never. Okay? Because technically what you did was take the square root, and you said, oh, square root of 1 is 1, square root of negative sine squared is sine, right? But we can't do that because of this minus sign. Remember that? Okay. Thank you for bringing that up because I think it is still a valuable learning tool. Guys, what do you see when you see a number that's a fraction times a number? What do you guys normally do to that? If you see a fraction times a number, still multiplying, but we multiply straight across, correct? So what do we, oops, not plus. What do we get there? Now I have a number plus a fraction. What does that make you think of doing? You guys agree with Taylor? When you see a number plus a fraction, a common denominator, sounds reasonable, doesn't it? So I'm going to times sine top and bottom. And if I have sine times sine, that makes me sine squared. Correct? What's the top become? Good. It wasn't meant to be a plus. It wasn't meant to be a equal sign. Hey, Giggles. It was supposed to be a plus. It's a plus. It's a plus. It's a plus. If you can't see, that's a plus, but that's a plus. Or I can erase it. Hold on, buddy. Don't. You and your horsies. Because they're the same denominator, I can add the top divided by the bottom, right? Doesn't 1 over 2 plus 5 over 2 equal 1 plus 5 over 2? Or 6 over 2? I don't multiply both sides, I multiplied the one side. Okay, what is the top again? Sine squared plus cosine squared is 1 over sine of x, which equals cosecant. We doing okay? Onward next to problem. Cosecant. I can't do that. That's why I don't like people teaching that way, because that's not a proper method when I have multiplication. I mean addition. By the way, when can you do cross multiplication? When you have like 1 over 2 equals x over 4. You see how you have an equal sign in between them? That's when you can. But we don't have that situation, do we? Which is doing what, Dan? which is called what? Which is true, which is called what, Daniel? Getting a common denominator? Right, Daniel? He is keeping up with the Joneses. It is equal to cotangent. But I could do that. I could. I really can. But because this one is a fraction as well, I'm not going to play with that. Lunchtime's over, guys. Tomorrow's the 75-minuter for those that really like it and those that don't. I'm sorry. Who's Heather Brogdon? Does she? She wants to be my friend. I don't even know who the hell she is. Why would she want to be my friend on social media? I do know quite of her friends. I have 34 mutual friends with her. She does make cakes. Yes, they are pretty. Ooh. All right, so what does the top become now? Because look at my common denominator. My denominator is going to be sine of x times 1 plus cosine of x. Now, to answer your question, Trek, as well, could you have done that and got the same result? Probably. You would have just had to work harder. Okay, what does the top become, though? I can distribute the cosine in. Is that what you're asking? So I get cosine x plus cosine squared. You could, but I'm not going to again. I'll show you why in just a minute. Once again, I can see it quickly. I can see that I don't need to because I can see 4 steps a little bit farther than you can sometimes. Does that make sense? Anyone? Know what we see? What do you got, Chris? Good old Larry. Come on, Larry. One's a trig identity up there sitting on the top. Don't everybody help him. I believe in you, Larry. Maybe it has to do with these two people. Oh, Larry got it. So isn't that equal to 1 plus cosine over sine of 1 plus cosine? What's the top and the bottom have in common? 1 plus cosine, so I can get rid of that. So we're left with 1 over sine, who is cosecant. So what tomorrow's lesson or next time's lesson is going to be like is kind of like this, because what did he equal? He equaled cosecant. So doesn't this equal that, the original here? So they're asking you to verify that they both equal each other. That's kind of what next time's lesson is going to be. So you have 2 sides to work with. Make sense? Now, today, guys, I will say the thing that I get frustrated with on today's lesson is I don't know where to stop all the time. This one's been pretty easy to stop. Let's show you this next example where it's not as easy to stop. And I want to know, where do I stop at? Okay? So, let's write this one. No? I was dancing. Nobody liked it. Thank you. Hey! Congratulations! Hey! She's eating a cannoli. Hey, that's the baseball team. Hey, Big Mac! What up, brother? You did already? Yeah. Did you open it? No. Why? Oh, you're one of those people. Did you put that you wanted to go anywhere? My niece, she said she wanted to have a shower via a bucket and live in the dirt. And she went to Africa. That would not be where I want to go. I'll be all like, can I go to Salt Lake? Okay. I will see what we can. All right, brother. All right, fair deal. Tell me, are you going to post it at least to say what time you're doing it? Okay. Well, no, meaning, will you say what time you're doing it? Holy shiznit, why? I'm like in bed at that time. That's late. Why so late? Okay, brother. See you. I know where he lives, so that's a little awkward. I parallel parked with his mama's car once for driver's ed. Okay, oops, not equals. Anybody know what we're going to do here? That's what we have. So really, that one's already kind of simplified. But they want us to make it look like something else, which we can't. Now, what I'm going to do here, does anybody have an idea before I start, before I even give a hint? What is that called? Did you look in the book? All right. Does anybody remember what this is called? Because I was about to say it's the person that's in prison that's drinking from an item that just got done eating. A person in prison, a con, some drinking out of an item, a jug, they just got done eating. Yes, we are going to multiply by its conjugate. What I do to the bottom, I got to do to the top, right? Any questions there? Isn't my handwriting so nice today? It's nice, huh, Dunk? What's the bottom become? What does difference of square? I mean, what does conjugate pairs multiply be? Difference of squares, son of a monkey. Something in your head should be ringing. Good. No. Hold your ponies. I love a good pony. We had a pony. Well, I didn't have it. It was my aunt's, but I always rode it. Her name was Stripe. That little thing threw me off more often than I could be on. It was fun times. I was really the only one that ever wanted to ride her. I thought it was a good time. One time I was in this and we were riding her bareback. Well, it was like bareback, but not really, because they had a pad that we could use. And I was riding her with this pad. We had no bridle on her. They're like, just let her run around. So she ran around and she jumped the darn fence with me on. That was fun. Good times. Then one time we were running through this field and there was a big old hole in the middle that we didn't know of. So I was running. We were like, like me and my cousins and my brother and everything. There was like 7 horses. We were like, right, busting through. My horse sees the damn hole, whoop, and I stop and I go, whoop, right in the hole. Right in the hole. No, it was just a big old hole. And then my cousins had to help me get out because it was a deep hole. Good times. Me and horses. I've been trampled by 2 horses. Let's go back to this question here. What's another way to write this? Don't tell me 1/3. If you tell me negative 1/3, I'm going to kick you in the shin. Thank you. Does everybody agree that this is 1/3 minus 2/3? So whatever's underneath, I can put it under each individual item, correct? Does that make sense? So this is 1 over cosine squared minus sine over cosine squared. What's another way I could write cosine squared? Just simple, not changing it. Isn't it cosine cosine? You guys agree with me? Any questions there? There we go, secant squared, right? Good. Does everybody see that? 1 over cosine squared is secant squared. Okay, so what about this right here? What about that? That one's tangent. Good. Over, I could have it over cosine, but I'm not going to. I can still have a 1 up top, can't I? And what's this? Another secant. And that's where they have it stopping. Nope. I don't know. I could see that happens to be here. And that's, like I said, that's where my frustration comes in with these, right? Because where do I really stop? And that's hard. That's why Bob's our friend today, right? Back of book. Good old Bob's going to be our friend because then we can check to see really where they're wanting us to go. Right? Does that make sense? Any questions there? Now it's your opportunity. If you guys would like to turn to page 379. Page 379. Any odd problem on page 379 or 380? Not odd, even. I'll do 3 more examples and we'll call it quits. You guys pick any number. Any even number. Because obviously they're not in the back of the book, right? Where's your book today? $36, and then, yep, 36. What does it say? Tangent squared over secant squared. Okay. Well, let's treat tangent squared. What's another name for him? I could say that this is the same thing as cosecant squared minus, secant squared minus 1. I could say that, but I'm not going to. Can somebody tell me another name for tangent squared? Very simple, very easy. Sine squared over cosine squared. How about secant squared? What's another name for him? Good, 1 over cosine squared. Then when I have a fraction over a fraction, I times the top by the bottom's reciprocal. And the reason being is because those guys cancel, huh? What happens here, though? Those guys cancel, so what does this end up being? Anybody else have one? I can just give you the homework and let you guys try. I'm just giving you opportunities. 38, what does it say? Cotangent squared of pi halves minus x times by cosine. Okay. Ladies and gentlemen, this is one of the identities that I'm not aware of, but I know how to make the identity work. Later, this identity can be very simple by another rule, so hence why I don't make you memorize this one. But if you guys would bear with me here, I'm going to draw a triangle, because all this is an angle. Would you guys agree that's an angle? Pi halves minus x, that's an angle. Okay, here's a triangle. I'm going to call him x. Can anybody tell me what this angle is right here? Let's say this guy was 50. If he's 50, what's this angle? How'd you do that, Trek? So therefore, what's this angle? 90 minus x. Because let's say he's x instead of 50. Isn't that pi halves minus x? Yes, no? Is everybody there with me? So let's say this. Let's say he's A, he's B, he's C. What's the cotangent of pi halves minus x? So let's stand up here. What's the cotangent of him? A over B, correct? What other trig function, if I stand down at this angle, equals A over B? Tangent, right, Connor? Because if I stand up here, cotangent is A over B, correct? But if I stand down at this angle, it would be A over B. Now, if you guys would turn to page 374, it is on there. Like I said, if you want to memorize it, it's awesome, but I just showed you where it came from. Did I get it right that cotangent of pi halves minus x is tangent? Whoever's on that page 374. It's on the very bottom. Cotangent of pi halves minus x is tangent. Page 374. Is it on there, McKay? And it equals tangent. But how did I find it? I drew a triangle. I just drew this triangle. Understanding that the cotangent of this angle equals the tangent of this angle. Okay? This is where I'm at. Can anybody tell me what tangent is? What do you got, Miss Pinkham? Sine over cosine? Times by cosine of x, which is just sine of x. You guys ready to rock? I'll do one more if you want, or you guys can start working on the homework. You may. Okay, I'm going to assume we're good. Once again, this is your homework right here. Maybe. Maybe. Where should she be? Right there. She's right here. There's the homework. Page 379, 5-1, 511, 15 through 63 odd, 73 and 75. Record this